Hi everyone. We're embarking on a pretty exciting portion of mobile development, learning how to consume web services via APIs. An API stands for Application Programming Interface. It is a library through which you can access data, functions, abilities of a third-party service like Facebook, Gmail, um, you know, Google Docs, all sorts of different services, very popular services out there. It's not a requirement for anybody to have an API, but it's more of a nicety. It's something that you offer to extend the interaction with your web service. So what we're going to do is we're going to write an app that actually interacts with a particular service that I've chosen, something simple. They do range in complexity. Some of them are quite simple to work with, and others are quite advanced. Some of them require authentication. Some of them you can access data anonymously. For this particular example, we will be using an anonymous access API. It actually comes from Weather Underground. If you're not familiar with it, the address is wunderground.com or .org. Unfortunately, I can't remember. This web service API that they've created allows you to submit a city name or a state name or a zip code and get the current weather conditions. If you actually pay for it, we're using the free version, but if you actually pay for it, you can get the 7-day forecast, multiple requests an hour. For what we're doing, we're going to use the free version because I'm not going to pay for it, and we don't require anything too advanced for our example. For this particular week's work, what we're going to do is we're going to submit a zip code, and we're going to get back the current weather conditions for that particular city. And it doesn't really, there's no restriction on what zip code you could submit. We're going to happen to use Columbus State's zip code, which is 43215. But you could submit any one that you want. And as a matter of fact, the homework for this week will be you trying to implement this with the given files and allow the user to type in whatever zip code they want instead of just a hard-coded one. So let's get started. What we're looking at right now is the REST activity. REST stands for representational state transfer. It is a type of protocol that typically APIs follow. It's heavily based off of HTTP. It's stateless, meaning that there is no information stored about your interaction with the API. So this particular activity is actually quite simple. If you'll look, you'll see that we do some pretty typical things here. We implement the weather.xml file. There are two text views within this weather.xml file. One is called cur_temp_f, and the other one is called cur_temp_c. What this does is this allows us to display the temperature in Fahrenheit and the temperature in Celsius simultaneously for whatever the given zip code is. On line 31, you'll see a creation of a REST object. This REST, it happens to be the rest.java file. This is a file which is provided to you. You don't have to create it. As a matter of fact, all the nasty work has been done for you. You just have to understand how to use it. All right. And on line 41, you see a call to a function in that rest.java file called getCurrentWeatherByZipCode. I happen to be passing currently the zip code of Columbus State. What this function returns is actually a weather conditions object. This weather conditions object is defined by a weather conditions class, which resides in rest.java. It is an inner class of REST class. It is nested within. So when you call this function, you actually have to create a weather conditions object to capture what's coming back from the getCurrentWeatherByZipCode function. Then very simply from there, all we have to do is say cscc weather dot get temp in F, and then dot get temp in C. And what that does is that accesses the temperature in Fahrenheit value and the temperature in Celsius value from the weather conditions object. And then consequently, what we're doing is we're passing that to the two text fields that were initialized in the above lines. That's all that this REST activity does. It initializes the variables, it connects up the layout, it makes a call to the predefined function, which has already been done for you, and then sets the data on the actual layout. That's it. The real nastiness, if we come over here, the real nastiness lies in this rest.java file. This rest.java file, like I said, is something that I've made for you. You should not be overly concerned with the details, but I'm going to give you a quick overview of exactly how it works. Okay, it's broken up into three sections. There is a private functions section, functions that are only to be used within the rest.java file. There is an inner class section, which I'll show you in a second, and a public function section, which are functions that are meant to be called outside the REST class. Here we are looking at a function. It's a public function, but it doesn't need to be. It's called get JSON from URL. What this does, this actually takes the URL that you give it, the URL which points to the Weather Underground API, calls that URL, grabs the data that comes back from it, and then turns it into a JSON object. And if you need more information on what a JSON object is, visit citWebDev week 7, and there's some extra information up there. You can find information all over the internet on it. It's a very, very common format. The API will also return it in XML, but it is much easier, in my opinion, to work with JSON rather than XML. Okay. So this function, you just need to know that that function exists. You don't even have to call it. That's not something that's meant to be called. There's also an equivalent function called get JSON string from URL. It does a similar thing, except it doesn't return a JSON object. It just returns a modified string from the server request. That's all. And here is our inner class. It's starting on line 89 is the inner class. The class is called weather conditions. This is the class that defines the weather conditions object, as you saw in the REST activity.java file. There are several properties associated with this weather condition object: the city name, the zip code, the temperature in Fahrenheit and Celsius, and then a weather description. This weather description, on a side note, is typically cloudy or overcast, sunny, rainy. Okay, this weather conditions object gets initialized either devoid of any parameters, or all the parameters. And then there's this is the part that you're going to be concerned with for your homework. There are public accessor methods for this weather conditions object. It allows you to take the object that comes back from a function call and actually get the data out of it: the city, the zip, the temperature in Fahrenheit and Celsius, and then the weather description. So beware that these are here. They're on lines 111 to 115. Above is a public function, a very important public function. It's called get current weather by zip code, and this is the function that we saw in the REST activity.java file. What this does is it defines the URL which points to the Weather Underground API. Okay, it makes a call to that API to get the data, and then what it does is it goes through and it tries to parse all the all of the JSON data that comes back from that API call. And on line 73, you'll see that it actually takes that extracted data and creates a weather conditions object from it and returns it. Okay, keeping line 73 in mind, where it creates the weather conditions object, we'll look back at REST activity.java, and we'll see that on line 41, this is actually where the object's being returned to, your null weather conditions CSCC weather object. Okay, that's what gets returned there, and that's where the information comes from. So all this stuff, it can be rather complicated. If you've never worked with JSON before, this may be a little unnerving, but you don't have to understand the JSON part of it. What I want you to focus on is the ability to call an API from Weather Underground and get live data back from a server. This is a very common thing for you to do as a mobile software developer, because that's pretty much the purpose of a smartphone, is to have to bring all of this important and relevant data and information to the palm of your hand whenever you want it. This is not the only thing that is useful. This is not the only API that is useful. There, like I said, there are literally probably dozens upon dozens of APIs available for you out there, but this just happens to be a slightly simpler one to work with initially. Before we exit, I just want to show you how simple the weather XML file is. Like I said, there are two text views that we work with. One of them is current temp, and the other one is current temp C. The other one is just a label. You can delete it. You can do whatever you want to it. That's fine. Here, I'll show you what it looks like. Go to graphical layout. Okay, that's all. That's what it's going to look like. Obviously, the numbers are going to be different depending on what zip code you pass it. But when you do actually run this, the values should be correctly displayed. Your homework is going to ask you to take basically what is here and create an app that allows the user to type in a particular zip code rather than just let it be the hard-coded zip code in the Java file. So you're going to add some interactivity to this. You don't necessarily have to modify anything with the API or the representational state transfer file, just with the user interface. Okay, so there's a lot to digest here. If you have any questions, feel free to ask. It's important to understand this, and really this is more of a show and tell that you can do something like this rather than you need to understand everything about this. I try to do a good job of documenting every line in the rest.java class, so that way you can go through there and perhaps on your own figure out how to use the API that you desire to use. But like I said, it's complicated, but it'll take a while to digest, but it is manageable. Let me know if you have any questions. Good luck.